we go, Algebra 2 students, another Regents review video coming right at you. This is the Algebra 2 Common Core Regents exam for the June 2016 administration for Algebra 2 Common Core. These are going to be the solutions. These are going to be the long ones. The solutions to parts 2 through 4 of this exam. Now, since this is the first time I'm doing the part 2 through 4 in a video, and I assume it's going to be like my other subjects, but I have a feeling that it's going to take over an hour. Just please bear with me, or you could just skip around. I don't really care, but if you need the whole thing, it's going to be taking a whole lot of your time, so sit tight, buckle up, get ready to go. Before we begin, as usual, do not cheat off of these videos. Don't do it. Please don't do it. It's not going to be helpful. No freaking way is it going to be helpful. Trigonometry, Algebra 2, well, Algebra 2 Common Core, it used to be called Algebra 2 Trigonometry, but Algebra 2 is a easy class, challenging regions. Make sure that you do the work by yourself first. Hit the subscribe button down below. Consider becoming a patron on my Patreon page. I would greatly appreciate the support, and I would be forever so grateful. And make sure that you visit my website at www.nysmathreadingsprep.com. Both the Patreon link and the link to my website are found in the description below. And another link that you need to know is the TI Inspire CX. This can be also found on my website. Just links you right to Amazon. This is the most powerful tool you could have for the Regents exam, and you'll see very quickly why you will like it so much. We're moving right on to the part 2s, 3s, and 4s. In my opinion, the part 2s of this exam are very quick. They're easier than the part 3s and 4s. I'm going to show you several ways to answer these questions. Here we go. Number 25 says solve for x. Easy peasy. So, the minute you see a whole bunch of fractions here, you should be thinking to yourself, least common denominator. So what you're doing is you're really looking at each denominator and you're saying, okay, how could I possibly make all of these look alike? Well, I see an x, a 3, and a 3x. So clearly your LCD is your 3x. Because all you need to do is you need to multiply this fraction by 3, multiply this fraction by x, and you don't even need to do anything to this one. Okay? So, what I'm going to do is I'm just going to rewrite this, make it a little bit neater. All right. Okay. So, I'm going to multiply this fraction over here by 3. What do you do to the bottom? You must do to the top. Multiply this by x and x. And this, we do nothing to it. Nothing at all, because the least common denominator is 3x. We don't need to change anything. So, I am then going to multiply. So we get 3 over 3x minus x over 3x equals negative 1 over 3x. Now, the minute this happens, when you are dividing by all of the same least common denominator, that's your goal, you are actually going to cancel out all of these numbers and you're just left with the top. Okay? So now you just solve the top piece. So we get 3 minus x equals negative 1. Continue to solve for x. Subtract the 3 on both sides. We get negative x equals negative 4. Divide by that negative 1 on both sides, and you get x is equal to 4. Ladies and gentlemen, that is the answer to that question. Now, let's just say you did not like the way I just did it. Too bad. It's a part 2. You need to show your work. But let's just say you want to check your answer. Go to your TI Inspire calculator. Go to your calculator page. Go to Menu, Algebra, and Numerical Solve. That was option 1, by the way. Just went really quick. So, I'm actually going to type in what I see on my page. 1 divided by x minus 1 over 3 is equal to negative 1 over 3x. Oh, my apologies. You need to type in comma x to solve it, because the calculator does not know what to do. And what do you know? Oh, it's x is equal to 4. There you go. They just told you on the calculator. So we know we got the right answer. Moving on to number 26. I remember when this exam was given, and the kids came out like, Trevor, there was a toothpaste question on our Regents exam, and it was like a science question. Why was a science question on our Algebra 2 Regents? What? It's not a science question, people. It's a statistics question. But again, let's just see what they're saying here. Describe how a controlled experiment can be created to examine the effect of ingredient X in a toothpaste. So here's what you gotta do. You need to know what a controlled experiment is. You are controlling the variables in the experiment. So there's got to be an independent variable and a dependent variable. Here's what we're going to say. The key to get this question right is a controlled experiment has to be randomly assigned. So randomly assign, that's the important piece. Randomly assign a large, diverse number of participants. Okay? Randomly assign a large, diverse number of participants to groups A and B. Okay? I'm going to say that group A is the control group. Which, by the way, the control group is a fancy term for the group that does not get any manipulation. So the toothpaste, like, let's just say you are analyzing Crest toothpaste and you are analyzing Trevor Clark's toothpaste. The control group will be the Crest, and the Trevor Clark toothpaste will be the Crest with ingredient X inside. That is called the variable group. All right, so group A is the control group where the regular toothpaste is used. Okay? As in, nothing has changed. You can put that in parentheses. I don't really care what you do with it. Nothing has changed. Okay? Now, group B is the variable, as I said before, the variable, or it's also called the experimental group. Okay? Where ingredient X is used. In the toothpaste. Okay? Then, all you need to say is conduct the experiment. And examine the results when concluded. That's it. That's all you need to say. Now, I actually personally put a like a star at the very end, and I was kind of a bit of a wise ass here, but like if I put this on my Regents, like the teachers, the teachers would be impressed, but like really, like this is just a wise thing to say. But you could say, for good, reliable results, this experiment should be conducted several times to get accurate results. Okay? Because if you only conduct it once, what good does that do? Right? So you really should be conducting it several times in order to get very accurate results. And that's how you do that question. Moving on to number 27. Okay, so I'm going to show you two ways to do this question. Determine if x minus 5 is a factor of 2x to the third minus 4x squared minus 7x minus 10, and then explain your answer. So there are two ways that I'm going to show you. I'm going to show you method 1, which is called the remainder theorem. Now, here's the thing, people. You should really use these videos with conjunction to my facts you must know cold for the Algebra 2 Regents exam. For example, if you don't know what I just said, that's a problem. You need to understand what the remainder theorem is. I highly recommend that you download that document on my website, and it tells you what the remainder theorem is. I just explain it in video. On the review packet, might not be so clear. This is where you get some clarification. But if you don't know what that is, or you've never heard of it before, that's a problem, and you need to get that fixed real quick. But let me just tell you what the remainder theorem is, just to give you some relief. So what you need to do is the remainder theorem is you take this factor, okay? You take this factor, x minus 5, and you set it equal to the number 0, and you solve for x. You add the 5 on both sides, and you get x is equal to 5. Now what you're going to do is you're going to take that 5, and you're going to plug it into the values of x that you see in your original equation. So we get 2 times 5 cubed minus 4 times 5 squared minus 7 times 5 minus 10. Now, here's why I'm doing this. If the output, if this thing results in the number 0, then x minus 5 is a factor. Okay? Now, if it does not equal 0, x minus 5 is not a factor. Okay? So if it equals 0, x minus 5 is a factor. If it's not equal 0, it's not a factor. So let's go ahead and solve this. I'm lazy. So if you plug all of this into your calculator, you get the answer of 105. 105 is not 0, ladies and gentlemen. That is not equal to the number 0. So therefore, since it's not equal to 0, we're going to say that x minus 5 is not a factor because the remainder is not 0. It's an ugly H. The remainder is not 0. Okay? That's one way you do it. That's called the remainder theorem. Honestly, not too bad. I'm going to show you the different way. You could actually use synthetic division to get this question right. Okay? So let's go ahead and use some synthetic division. So for synthetic division, all you're going to do is you're taking this factor, you set it equal to 0, you get x equals 5. But for this time, what you're doing is you're using the coefficients of the polynomial and the factor that you're trying to find, and you're trying to find if this number in this box, which is, remember, when you perform synthetic division, the number that is in its lonesome corner by itself is the remainder. Is that number 0 or not? Well, we already know it's going to be 105, but let me just show you the steps. Bring down that 2, start multiplying. 5 times 2 is 10. 10 plus negative 4 is 6. 6 times 5 is 30. 30 plus negative 7 is 23. 23 plus 5 is 115. 115 minus 10 is 105. Clearly, that is not a remainder of 0, so it does not equal 0. So for your answer for this explanation, we're going to say that x minus 5 is not a factor because the remainder is not 0. Same explanation, just different work. Okay? Not too bad of a question. You gotta know both of those theorems, the remainder theorem and the synthetic division. Okay, moving on to number 28. On the axes below, graph one cycle of a cosine function with an amplitude of 3, a period of pi over 2, a midline of y equals negative 1, and passing through the point 0, 2. Okay, so a couple things real quick. We know that the cosine curve has a general form of y equals a cosine b of x plus c, where a is your amplitude, b is the frequency, and c is your vertical shift, up or down. So the a in this case, which is your amplitude, they tell you it's 3. Your b, which is the frequency, we don't know it. We got to find it. Now, what you should know by now is that period and frequency are directly related with a formula. Okay? The period of a function is really 2 pi over b. Okay? Where b is the frequency. That's how they're directly related, ladies and gentlemen. So they tell you that the period is pi over 2. So we could actually take pi over 2, set it equal to 2 pi over b, and solve for the frequency that way. So when you cross multiply, you get 4 pi equals pi b. Divide by pi to solve for b. Okay? And you get b is equal to 4. Ladies and gentlemen, that is the frequency. Okay? So we actually just found it. All right? So I'm going to erase all this. So we get b equals 4. Okay? Now your c value is it's negative 1. If the midline is directly passing through the middle of that cosine curve, so it's just being shifted downwards by a negative 1, so your c is negative 1. So what you're really graphing here, folks, is you are graphing the equation y equals 3 cosine 4x minus 1. You're graphing that function on this graph paper. Okay, so it's passing through the point 0, 2. Okay, 0, 2 is right here. I'm going to draw my midline. Draw it in purple. I'm going to draw my midline. Y equals -1. That's right there. Okay? And the amplitude is 3. Okay, let's make sure this is 3. 1, 2, 3. Definitely 3. So we got to go 3 above, 3 below. And we are graphing, let's see, a period of pi over 2. So let's talk about what period means for a second. Period means that the curve itself completes one full cycle in pi over 2 radians. So what I'm telling you is you want to graph one cycle with pi over 2 being at the very end. So the 4, I don't want to say it's irrelevant. It's really not, because because it says like graph one cycle of the cosine function. They really want you to find that, which we just did. So basically what we're doing, if we're starting up here, we got to go down and we got to end back up here. Now that is not drawn to scale. I'm just showing you a general gist of it. So the amplitude is 3. 1, 2, 3. Go down 1, 2, 3. So your dot has to be somewhere on that line and has to end over here. Well, it's easy. Just go right in the middle of the 2 dots, and you got the right answer. Boom. Got it. Go right in the middle of those 2 dots, and you have your cosine function, or one complete cosine curve. Whoop. Nope. Back it up. Boom. Boom. Done. Now label. Y equals 3 cosine 4x minus 1. And you, ladies and gentlemen, are done with that question. Moving on to number 29. Ooh, probability question. Now, here's the thing. You're going to see a lot of videos for Algebra 2. Probability is not my favorite, but I could still teach it to you. But just understand, like, if I feel that I'm not explaining it well, I'm going to explain it again. So just bear with me, please. But probability, it's so not my thing. I hate it. I hate it. I hate it. Ugh, whatever. But I got to teach it because it's my job to make sure that you do well. Okay. Besides the point, here we go. A suburban high school has a population of 1,376 students. The number of students who participate in sports is 649 people. The number of students who participate in music is 433 people. If the probability that a student participates in either sports or music is 974 over 1,376, what is the probability that a student participates in both sports and music? Wow. So this is a part 2 question, but it's wordy. It's very wordy, people. So here's how I like to do this. I like to draw myself what is called the population of the high school, okay? And I'm going to draw 2 circles. It's kind of like a Venn diagram that you did in English class, comparing 2 words, okay? So I'm going to draw a Venn diagram, and I'm going to call this bubble, this circle, I'm going to call this sports. I'm going to call this music, okay? So for sports, we don't know how many people there are. Now it says here the number of people who participate in sports is 649. But the problem is here, people, that you can't just put in 649, 433, call it a day, and walk away. No. Because it's asking you specifically, what is the probability that a student participates in both sports and music? Some of these kids in the 649 and the 433 could participate in both. So what we need to do is this. I'm going to call this letter A. Oops. I'm going to do that in blue, though. All right. I'm going to call this letter A. I'm going to call this letter C. I'm going to call this letter B. I'm going to call this letter D. And you're going to I'm going to explain why I'm doing this all anyway. So letter A in this scenario is the region, and I suggest you copy this down. A is the region of students who participate in sports only, not music, okay? Region B, which is the middle, it's obviously it's the region where they participate in both. So it is the region of students who participate in both sports and music. That is like a quadruple M. I don't know what that was. Okay. Region C, as you could assume, that it's just the people who only participate in music. So it is the region of students who participate in music only. And region D. Region D is the outside. Now who are those people? Well, it's the region of students who don't participate in anything. Spell that wrong. Participate in anything. Okay? So, let's talk about this in terms of equations. Okay? You know for a fact that region A plus region B has to equal 649 because region A and B consist of students who participate in sports. We know that. But we don't know for sure how many people are in B that participate in sports. So we know that the people in just sports plus region B, which could participate in both sports and music, must equal 649. Okay? And the people in region B plus the region C must equal 433. Again, there's that overlapping. The 433 people could participate in music and could participate in sports. So, what we could do is if we actually add these numbers together, the 649 plus the 433, we get an answer of 1082. Now, what does that tell us? Well, if we take the 1082 and we subtract the 974, because that's the number of people, or sorry, that's the probability that a student participates in either sports or music. So we are actually taking the total amount of people who participate in sports and music and subtracting the 974, which is the probability of them participating in both. That equals 108. Ladies and gentlemen, I just wrote 180 like it's geometry. 108. Ladies and gentlemen, the probability that a student participates in both sports and music is 108 over 1,376. That is your answer. So if I were to fill it in for you, this would be 108. The A value would be 649 minus 108, which would be 541. C would be 325. It's just that 433 minus 108, that gives you 325. And the D part, that's your 402. That is just subtracting everyone from the mix. All right, and that's your answer how you do that question. Honestly, ridiculous part 2 question for probability. Okay, moving on to these are my favorite. Number 30. The directrix of a parabola, 12 times y plus 3 equals x minus 4 squared, has the equation y equals negative 6. Find the coordinates of the focus of the parabola. So I love writing all my information down because I know it by heart. And I know that you will too. The vertex of the parabola is always written in the form of h comma k. Okay? The focus of the parabola is always written in the form of h comma k plus p. All right, I'm going to show you how to do this algebraically and then graphically, because there's a way to do it on the graphing calculator. I know, right? It's a lot of fun. The directrix is y is equal to k minus p. And the vertex form of a parabola, which you learned this year, you barely learned it in Algebra 1. You only learned ax squared plus bx plus c. But the vertex form of a parabola is y equals 1 over 4p times x minus h squared plus k. That is an ugly k. Don't know what that was. Okay. So, they tell us that the directrix equation is y equals negative 6. Ladies and gentlemen, I just told you that the directrix equation is in the form of y equals k minus p. So what we know for sure of y equals k minus p, we could actually replace the k minus p with the negative 6 and then vice versa. Or we could say that k minus p equals negative 6. Because if y equals 6, then y equals k minus p. This is known as, remember in geometry and algebra, the transitive postulate. right? If A equals B and B equals C, then A must equal C. Same thing going on right here. So what we could do is this. We're trying to find the main idea is trying to find the focus, okay? The focus, we have no idea what it is. We're trying to find that K plus P first, okay? So let's go ahead and calculate what the values of K and P might be, okay? So I'm going to take that -6, I'm going to plug in it for Y. So we get -6 equals K minus P. Now, do we know any K minus P value? Do we know it? Well, no, not yet. So what we need to do is something even before this. We actually need to convert this into that form to find the vertex. Because if we convert it, we could easily find the vertex if we're given in this form. So let's go ahead and do that. So if we take 12 times y plus 3 is equal to x minus 4 squared. Now you see how complicated the part 2s are for algebra 2. Divide by 12, okay? So we get y plus 3 equals 1/12 times x minus 4 squared. Now I'm just going to subtract the 3. Okay? So we get y equals 1/12 times x minus 4 squared minus 3. Ladies and gentlemen, this is the vertex form of the parabola. Let's go ahead and find the values, or the vertex values. The vertex is h comma k. So the vertex of this equation is hk. Here's the h, here's the k. It's -4, -3. But the vertex, now keep in mind here, that this is a horizontal shift to the right by 4 units. So that means that the 4 is positive, the -3 remains negative. So your vertex is 4, 3. The 4 is your h, the 3 is your k. Okay? That is just your basic transformation rules that you have to know that that's opposite and that's the same sign. Now we know h and k. Hey, I just found k to be -3, right? I just said that k is -3. Plug it in. We get -6 equals -3 minus p. Add the 3 on both sides. We get -3 equals -p. P must equal 3. Sweet. We have our p value, we have our h value, we have our k value. Trying to find the focus? Oh, sweet. Look at this, people. The focus is easy. The focus, we just found our h value. Our h value is down here, which is 4, comma. We got our k value, which is -3. We got our p value is +3. So -3 plus 3 is 0. Your focus is 4, 0. There you go. That's how you do that question. Not too bad. Just have to know your stuff. Moving on to 31. Algebraically prove that this is equal to this, where x is not equal -2. So basically what you got to do is you need to solve for a least common denominator. Okay? So we got to find a least common denominator of this. So a least common denominator is x to the 3rd plus 8. So x to the 3rd plus 8. Okay. So let's go ahead and do it. So we get x to the 3rd plus 9 over x to the 3rd plus 8 is equal to 1 over 1 plus 1 over x to the 3rd plus 8. Remember what we got to do. We need to multiply whatever fraction does not have an x to the 3rd plus 8 in the denominator. Okay? So, in this case, I got to write that down. Hold on one second. It looks so sloppy. Give me 1 minute. 1 over 1. That's better. So, I'm going to multiply this over here by x to the 3rd plus 8 times x to the 3rd plus 8. Okay? So, we get x to the 3rd plus 9 over x to the 3rd plus 8 is equal to x to the 3rd plus 8 divided by x to the 3rd plus 8 plus 1 over x to the 3rd plus 8. Now remember, when you get this stuff down here, cancel those out. And now we just have x to the 3rd plus 9. Does that equal x to the 3rd plus 8 plus 1? Well, we could combine that 8 plus 1. X to the 3rd plus 9 does equal x to the 3rd plus 9. Now to algebraically prove it, you just put a little check mark over the equal sign. That's how you algebraically prove it. You could even put a little smiley face and say algebraically proven. Done. And that is your answer to that question. All right. Are we almost done? Yeah, one more part 2, then we're going to part 3s. Oh, God. Okay, here we go. A house purchased 5 years ago for $100,000 was just sold for $135,000. Assuming exponential growth approximates the annual growth rate to the nearest percent. So, by now, I hope that you know this. You should know that the exponential growth or decay is indicated by the equation a of t equals p times 1 plus or minus the rate raised to the t power. Does that look familiar? Yeah. Algebra 1. You had to know it in Algebra 1, and it's back. It's back. It's right here. Let's do it. So, it was just sold for $135,000. So your a of t is $135,000. Your p value, which is the principal, is $100,000. That was the initial purchase amount. The rate is what we're trying to find. The t is 5 because it's 5 years. So what we're going to do is we're going to plug all this information in. And by the way, it's exponential growth. So we're only using the plus piece, not the minus. So I'm going to plug all this information in. We get 135,000 is equal to 100,000 times 1 plus the rate raised to the 5th power. Now we're going to solve the best we can. Divide first by 100,000. Remember, we're trying to solve for r. Cancel all those out. So when you reduce this fraction in your calculator, you get 27 over 20 equals 1 plus r to the 5th power. Now, to get rid of that 5, peoples, we got to take the 5th root of this. Take the 5th root of this. So when you take the 5th root of something raised to the 5th power, this just goes to 1 plus r. And I'm actually going to take the 5th root of this. So go to your calculator. Type in the 5th root. So control caret, the 5th root of 27 over 20. You get that disgusting number. So just transfer that over to your paper. So you get 1.06185875879 equals 1 plus r. Subtract that 1 on both sides, and you get the rate is equal to 0.06 when you round it to the nearest percent in this case. So if you move it back 2 more places, you get the answer of 6%. Ladies and gentlemen, that is the answer to that question. 6%. And that's it. Okay, here we go. Moving on to the part 3s. Part 3. Okay, this one, definitely a long question, but not difficult. Not overly difficult. Solve the system of equations shown below algebraically. So, algebraically means that you got to show work. So here's what we're gonna do. Well, I'm gonna show you how to do it algebraically. I'm gonna show you how to do it on the graphing calculator, to make sure that your answer is right. Okay. So the first things first is we got a circle here and we got a line. So we got to get rid of one of these variables. Which one do I want to get rid of? Well, I want to get rid of the y's. So how do we do that? Well, the first thing we got to do is we got to solve for x. Okay, how do we solve for x? Well, you need to do what's called substitution. Okay? Substitution means that you see a relationship between the circle and the line in terms of the variables. If I actually take this line and I divide everything by 2, okay, to solve for y, the 2's cancel, the 10 divided by 2 is 5. So what this breaks down to is you get x plus y equals 5. You're trying to put this in y equals mx plus b form, right? It's a line. So just subtract the x. You get y equals negative x plus 5. Ladies and gentlemen, now what we could do is take this and substitute it in for where you see a y. Well, you see a y right over here. So make that y equal to negative x plus 5. Now we're dealing with one variable. That's good. That's a good thing. We cannot deal with more than one variable when solving for it. So we get x minus 3 squared plus, now I'm replacing this. So we get negative x plus 5 plus 2 squared equals 16. So we get x minus 3 squared plus we get 7 minus x squared equals 16. Okay. So what I'm going to do is I'm going to expand this, then FOIL. So we get x minus 3 plus 7 minus x, 7 minus x. Yes, people, get ready to write. It's going to be a lot. So we're going to FOIL these. X times x is x squared. X times negative 3x is negative 3x. Negative 3 times x is negative 3x. That gives us a plus 9 at the end. Negative 3 times negative 3 is a positive 9. Plus 7 times 7 is 49. 7 minus x. Well, 7 times the negative x is negative 7x. Negative x times the negative... No, positive 7 is negative 7x. Negative x times negative x is plus x squared. That equals 16. Now we're going to combine like terms. That'll work. All right, so we get, let's see, x squared combines with an x squared. All of these x's could combine with each other. And the numbers could combine to each other. I'm just going to move that 16 over. So when you combine all this, ladies and gentlemen, when you combine everything, you get 2x squared minus 20x plus 42 equals 0. Now we're going to solve for x. Let's keep going. We need to take out a 2 first by factoring, GCF. Then we're left with x squared minus 10x plus 21. That equals 0. Okay? Now we're going to factor this. What adds to negative 10 but multiplies to give you positive 21? Your answer is x minus 3, x minus 7. That equals 0. Now we're going to t-bar it. Just take its opposites. X equals 3, x equals 7. Okay, that is one step to this question. By the way, all of that would only give you 2 points out of the 4. So now what we need to do is we are going to take our answers and plug them back into this equation up here, y equals negative x plus 5, to solve for the values of y. Okay, so let's go and do that now, shall we? So I'm going to solve for y. Here we go. If I get my mouse right. Solve y. So I'm going to take my y equals negative x plus 5 equation, just because it's so much easier to use, right? So I'm going to solve for when x is equal to 7. Then I'm going to solve for when x is equal to 3. So when x is equal to 7, I get y equals negative 1 times a 7 plus 5. That equals negative 2. Okay, so y equals negative 2 when x equals 7. Then over here, we get y equals negative 1 times a 3 plus 5. We get y equals nope. Is that 2 as well? Yep. Oh, it's negative. Okay, y equals 2. So now that we got that, it literally says solve the system of equations algebraically. Well, peoples, we got the x and y's. So now just put in your swirly brackets, put an ordered pair. 7 comma negative 2 is a intersection point, and 3 comma 2 is an intersection point. That is your answer. That's how you write it too. We're all done with that question. Now, to check yourself before you wreck your grade, or wreck yourself, let's go ahead to the graphing calculator. I'm going to show you how to do it. Make sure that your calculator is updated as much as possible. If you don't know how to do it, ask your teacher. They'll know how to do it. Actually, I might make a video on how to update your calculator. Who knows? So, what you're going to do is this, okay? You are going to go to Menu, go to Graph Entry Edit, and click on Relation. Relation allows you, on this calculator, to type in anything free, what you want, okay? So, I'm actually going to type in my equations that I see on my paper. X minus 3 quantity squared plus y plus 2 quantity squared equals 16. Okay, we got that circle. Now I'm going to type in another one. 2x plus 2y equals 10. Great. So we have these relations, right? So what I'm now going to do is I'm going to find my intersection point. So go to Menu, Analyze Graph, Intersection. Now what's nice is they give you a little crosshair here. So you click somewhere up here and it creates a shaded region like this. So one of the intersection points is 3, 2. Menu, Analyze Graph, Intersection. Let's find this one down here. Negative 7, 2. Aren't those the points that we just found, peoples? Oh, that's not that. Oh, that's me. We get 7, negative 2 and 3, 2. Yeah, we got those answers. Perfect. We got it right. We know for sure we got it right. All right. That's number 33. Moving on to number 34. Alexa earns $33,000 in her first year of teaching and earns a 4% increase in each successive year. Write a geometric series formula, S of n, for Alexa's total earnings over n years. So her starting amount, which is your A sub 1, is $33,000. The rate of increase is 4%, which is the same thing as 0.04. Now remember that your geometric series formula can be found on your reference sheet. The geometric series formula is right here. It's A sub 1 minus A sub 1 times r to the n over 1 minus r. But keep in mind that rate, you have to add a 1 to it. Why are you adding a 1? Because it is a rate of increase. She's getting paid more. Okay? She's getting paid more. So S of n is equal to 33,000 minus 33,000 times 1.04. That's the rate of increase. Raised to the n power. We don't know how many n's there are for years. Over 1 minus 1.04. Done. Not too bad. Now let's take a look at this. Use this formula to find Alexa's total earnings for her first 15 years of teaching to the nearest cent. Great. So all you're doing is you're making n equal 15. Plug it in, see what you get. So S of 15 equals 33,000 minus 33,000 times 1.04 to the 15th divided by 1 minus 1.04. Now, when you approximate that to the nearest cent, it's going to be a lot of typing. Oops. And we got 1 minus. Okay, and we get $660,778.39. So 660,778.39. That is to the nearest cent, ladies and gentlemen. And that is your answer. That's how much Alexa earns in teaching. Honestly, that is not a lot of money for 15 years of teaching. In New York State, you're earning easily over a couple $1 million. But then again, the taxes are higher here. So anyway, number 35. 55 students attending the prom were randomly selected to participate in a survey about the music choice at the prom. 60% responded that a DJ would be preferred over a band. Members of the prom committee thought that the vote would have a 50% for the DJ and 50% for the band. A simulation was run 200 times, each of sample size 55, based on the premise that 60% of students would prefer a DJ. The approximate normal simulation results are shown below. So let's talk about this. And again, I said this in an earlier video. I don't know why they're doing this. What they're doing is they're taking they are taking a survey of what they're doing, and then they're comparing it to a simulation done in a computer. Don't know why, but whatever. So you got to know what you're talking about here. This is the computer simulation. Okay? This is the computer simulation. This is what they actually asked the people who were going to the prom. Take a look at the mean here, folks. The mean is 0.602, and the standard deviation is 0.066. You need those badly. You need to know what those numbers are. So it says here, using the results of the simulation, the computer simulation, determine a plausible interval containing the middle 95% of the data around all values to the nearest hundredth. Ladies and gentlemen, you need to know that the middle 95% of data is your mean plus or minus 2 standard deviations. So you need to know that you're going from the mean, you're going back 2 standard deviations, and you're going forward 2 standard deviations. Okay? So what you're doing is you're taking the mean, which is 0.602, and you're first adding 2 times the standard deviation of 0.066. Okay? And you're taking the mean, 0.602, and you're subtracting 2 times the standard deviation. When you get these numbers, your interval is this. So the plausible interval is this, from 0.47 to 0.73. That is the plausible interval in this case. So they have that. Then there's a follow-up question. Members of the prom committee are concerned that a vote of all students attending the prom may produce a 50-50 split. Explain what statistical evidence supports this concern. So what they're asking you is take the interval that you have based on the computer simulation and compare it to the people who they are surveying. And remember, ladies and gentlemen, a survey is just a selection, a small selection of people. Just like presidential polls, for example. Presidential polls, you can't ask every single person in the country who they're voting for. First of all, not everyone is allowed to vote, meaning if you're younger than 18 years old, not everyone votes, and not everyone tells the honest opinion. I don't want to get all political here, but the political polls in the 2016 election were not accurate, and the silent majority came out and they voted for Trump. So I'm just throwing it out there that, you know, statistics can be wrong, right? But in this case, forget that. But in this case, what they're saying is that they're concerned for a 50-50 split, right? So they're comparing the computer simulation to the real life scenario. They're saying that the interval on the computer is 0.47 to 0.73. They're concerned about the 50-50 split. Why are they concerned? And they are absolutely right to be concerned because of this. Their concern is valid. It's totally validated because 0.50, which is the 50% or 50%, is within the plausible interval. So a split is still possible. Now let's just say, hypothetically speaking, that the interval was 0.51 to 0.73, just making it up. Then they would not have an argument for their case because it would be outside the plausible interval, and the possibility of a 50-50 split would not be entirely possible. I don't want to say it's impossible, but the chances of it being a 50-50 split in that case would be slim to none. Okay? But again, statistics can be wrong. Number 36. Basic Algebra 1 question, peoples. 36 says, which function shown below has a greater average rate of change on the interval from -2 to 4? Justify your answer. So greater average rate of change means which of the following has a greater slope? Okay? So we are looking at from -2 to 4. From -2 to 4 on the f of x, and the g of x, we got to actually evaluate those. So to find the slope of the f of x function, remember, change in y over the change in x, which is your slope formula, which is y2 minus y1 over x2 minus x1. You get 80 minus 1.25 over 4 minus a -2. Your slope is 13.125 when you evaluate that fraction. Now, to solve for the slope of the g of x equation, let me show you how to do this. What you're doing is you're taking the inputs of -2 and 4 and you're plugging them in. So let's go and find g of -2. So g of -2 is equal to 4 times -2 to the third minus 5 times -2 squared plus 3. We get g of -2 is equal to 4 times, that's going to be a -8 when you cube that. It's going to be minus 5 times 4 plus 3. G of -2 is equal to -49. Okay? That is your output. That's your y value. Now, g of 4, that's going to be 4 times 4 cubed minus 5 times 4 squared plus 3. G of 4, that is going to be 179 when you evaluate that. Now just calculate the slope. So the slope, which is again change of y over change of x, that is going to be 179 minus a -49 all over 4 minus a -2. That slope, when you evaluate it, that's the slope of 38. So, saying which function shown below has a greater average rate of change, your answer is g of x. G of x has a greater average rate of change on the interval -2 to 4. Done. There's your explanation. Or really the justification is your math, but you just have to put it in a sentence. Are we on to the last question? Yes! Yes, 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 yes. Okay, last question. It's going to be a pain in the ass, but that's okay. 37. Drugs break down in the human body at different rates and therefore must be prescribed by doctors carefully to prevent complications, such as overdosing. Yeah, pretty important stuff, right? You don't want doctors to be overprescribing stuff. The breakdown of a drug is represented by the function n of t equals n sub 0 e raised to the negative rt, where n of t is the amount left in the body, n sub 0 is the initial dosage, r is a decay rate, and t is the time in hours. Patient A of t, is given 800 milligrams of a drug with a decay rate of 0.347. Patient B of t, is given 400 milligrams of another drug with a decay rate of 0.231. Write two functions, A of t and B of t, to represent the breakdown of the respective drugs given to each patient. That's a lot of words. So, here we go. I'm going to say this. I'm going to make A of t blue. So we're going to find A of t, and we're going to find B of t. Okay? Here we go. A of t. A of t is given 800 milligrams with a drug decay rate of 0.347. And B of t is given 400 milligrams of another drug with a decay rate of 0.231. And the general equation is this up here, okay? So, the A of t rate, your initial dosage is 800. The letter E with a decay rate of negative 0.347, they tell us that, and with a T. We don't know how much the T is, okay? And the B is 400E to the negative 0.231 T. Ladies and gentlemen, those are your answers to the first part of that question. Not too bad. Now, for the next part, we just need to graph them. This is going to take forever. Okay, graph each function on the set of axes below. So, oh god, I'm so lazy. I see, I should do it on the calculator for you, but I'm not going to because it's so long. I have the answers right in front of me, so might as well just draw yourself a table of values. So we got this. I'm going to draw myself a table of values, so I'm going by twos here. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So for A of t, the blue function, okay, the blue function, 800, 400, 200, 100, 50, 25. So, of course, you're having everything. So 12, 6, 3, 1.5, dot, 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 dot. What is that, 0.75? Yeah, 0.75 at the end. And I think that I rounded all those. You don't get those numbers on the calculator. You actually have to round everything. Okay? And B of t, which is, again, x and y. Not much is changing. Okay? 0, 3, 6, 9, 12, 15, 400, 200, 100, 50, 25, approximately 13. Okay, but they get so astronomically small at the very end that you might as well just not even include them. So I'm gonna count by 50s. I'm really counting by 100s, but I'm skipping the line, so I'm really counting by 50s on the graph. So this is 100, this is 200, this is 300, this is 400, this is 500, this is 600, this is 700, this is 800, this is 900, and this is 1,000. I like to make everything even. Then down here I'm counting by ones, really counting by twos, but I'm skipping each one. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now you see why they give you 3 hours for this test. A lot of work. So I'm going to go ahead and graph my blues first. So 800. This is 400. Okay. Then I graph 4, comma 200. Then I graph 6, comma 100. Then 8, comma 50. That's right there. Then it starts to get really small, to the point where it doesn't really matter anymore. Now for the red, 0, 400, we get this. 3, we get 200. So in this case, I counted by 3s. That was the best thing to do. Then 6, we get 100 right there, about 100. Then at 9, you get 50. Then 12, you get 25. And then 15, you're about there. Okay, so I'm going to draw this to the very best of my ability. Please bear with me. It's going to be disgusting, but I'll see what I can do. Okay. Ugh, Jesus, this is... Freehand on this is... Oh, God almighty. What was that? Okay, hold on. Let me draw this. Slowly. Oh, getting there. Yeah. Mess up at the end. That's okay, though. I'm going to draw this. I thought you... There we go. Boom. Boom. Okay. Obviously, you draw much better than I do. I don't know what that is. It's very hard to draw with the thing I use, so just bear with me with that. Okay. So that's how you... If I can zoom in correctly. Okay, so that's how you do that part. Label it, please. A of t equals 800 e to the negative 0.347t. And this over here, this is b of t equals 400 e to the negative 0.231t. Now, what's nice about the Regents exam, you can't use colored pens, but if you bring highlighters to your exam, you can actually highlight like the graphs, and you could highlight the words. So if you have a blue highlighter, you could shade that blue, and then you could shade this blue. It's very nice what they allow you to use on the exam. You can use highlighters, and I highly recommend that you do bring those. Now, here we go. To the nearest hour, when does the amount of the given drug remaining in patient B begin to exceed the amount of the given drug remaining in patient A? So, they don't need you to solve this. They don't need you to do any algebra. They want you to see here, when do they cross? They cross when t equals 6, the 6th hour. And you could even say this is shown on the graph. Okay? Now, the last part is the more work part. Here we go. It says here, the doctor will allow patient A to take another 800 milligram dose of the drug only if 15% of the original dose is left in the body. Determine to the nearest tenth of an hour how long patient A will have to wait to take another 800 milligram dose. So here's the thing. The initial amount that the patient took was 800 milligrams. We want to calculate 15% of that 800 milligram dose. So I go to my calculator and say, all right, 800 times 0.15, okay? The patient could take another dosage of the 800 milligrams when the amount remaining in the patient's body is 120 milligrams. So we're basically trying to find when is 120 milligrams equal to the equation 800e to the negative 0.347t. Why am I setting it equal to that? Well, because we're trying to find t. We're trying to find how much time needs to pass to get to that 120 milligrams, okay? And that t will tell us, hey, patient A, you could go ahead and take that drug in this many hours. So let's go ahead and solve for it. Now, if you're thinking in your head, yo, Trevor, I got to use like logarithms, right? Yeah, you do. Here we go. Use logarithms. We're going to divide by 800. Divide by 800. 120 divided by 800 is 320. Is equal to e to the negative 0.347t. Now, it's up to you. You could either write log or you could write ln. I would rather write ln because you're dealing with natural log of e, which is just 1. And if you don't know that property, that's another reason why you need my facts you must know cold for the Regents exam. Just saying. So I'm going to move that out front. Okay, so we get I don't know what that was. So we get 320, 3 over 20, equals negative 0.347t. Now, the minute you move that exponent down, you got to write ln of e. Now, once you take the natural log of one side, you got to take the natural log of the other side. So, the natural log of e, you should know it's just 1. 1 times anything is just itself. So now we're going to divide by negative 0.347 on this side, and divide it over here as well. What do you do to one side, you must do to the other. Those cancel. And we get t equals whatever that number is. So go to your calculator, control division, the natural log of 320 divided by negative 0.347. And you get an answer of 5.46. 5.467. Now they want you to do it in nearest tenth of an hour. So your time t equals 5.5 hours. Ladies and gentlemen, that is the answer to that final piece of that question. And that is the yeah, that is the end of this exam. Algebra 2 takes forever to do. Now you see why I waited so long to do these videos. But anyway, besides the point, I hope that you enjoyed my wonderful voice and my dry humor whatsoever. Anyway, forget that. Make sure that you hit that subscribe button down below. It would help me a lot, make me feel a little bit better what I'm doing. Consider becoming a patron on my Patreon page. That link is in the description below. It will help me out a lot as well, and I thank you for your never-ending support. And make sure that you visit my website at www.nysmathreadingsprep.com for more math content in Algebra 2, and I hope to see you soon.